So let us begin with the seventh problem in this series, and the seventh problem in this series is problem number 1.205. The problem is stating a double star is a system of two stars moving around the center of inertia of the system due to gravitation. Find the distance between the components of the double star if its total mass equals capital M and the period of revolution is capital T. So let us begin this problem by drawing the situation which the problem is discussing. So this is how we can picturize a double star system. So over here, if I fix the coordinate system at M1 and let us determine the center of mass of the system, which is located somewhere over here at C, and the distance is RC. So over here, if we solve for RC, then we can say that RC equals M2R upon M1 plus M2. Now the problem wants us to calculate R. So this is RC, about which M1 and M2 both are going around in this circular path. So over here I can say that after a certain time t, this system is going to look like this. So we can picturize that M1 moves from this point to this point after a certain time t, and M2 moves from this point to this point after a certain time, but the position of center of mass remains unchanged. So over here we can say that if it is moving about C, and we say that if it is moving with a angular speed omega, then we can apply force equation for equilibrium of particle 1 and 2. So for particle 1, we can say that the force of gravitation, that is G m1 m2 by r square, is balanced by m1 omega square r, where r is equal to rc. So if we put the values over here, then we can say G m1 m2 by r square is equal to m1. So omega square can be written as 2 pi by t square, and then we have rc, which we have already evaluated. So m2r upon m1 plus m2. So we are solving for a small r, that is the separation between the two. So if we cancel this out, so m1 m2 cancel out. M1 plus M2 is the total mass of the system, that is capital M. So therefore we can say that R cube equals G capital M, that is M1 plus M2 upon 4 pi square and then T square. So this is the expression for R that we have, and if we just cube root the expression, so we can write it as GMT square by 4 pi square and this power 1 by 3. So this is the final answer for this problem, problem number 1.205.